typing it, whatever. I don't know. Okay. So,
I can say it this time.
Okay.
thank you.
Dear Heavenly Father, thank you for this wonderful day today that we have and the blessing and opportunity we have to get an education through BYU Idaho. Please be with us now as we go over our preparation, that we will be able to understand the material and be able to help one another out and to remember these things as we continue forward. We're grateful for thee, we love thee, and say in the name of Jesus Christ.
Amen.
Amen.
Thanks.
Thank you.
Yeah. So, any questions on preparation?
Let me look.
Lesson 4 is pretty easy.
It was pretty straightforward. It was only like so many questions too. Nope, I don't think I did.
Alright. Well, if no one has questions, I vote we go ahead and get started.
Alright. Oh, I'm on lesson 5.
But they get started on the group exam?
Mm-hmm.
Okay, just making sure.
Alright. Let me.
So we go directly to the quiz, right?
Yep. Lesson 4, group communities.
Okay. I hate doing the blank answers.
I know those stress me out.
They stress me out.
I wish they just had multiple answers, you know?
Exactly. Sorry, I'm gonna grab a pencil.
Okay. So does someone just want to start off and we can read question 3, 4, and just go through?
Yeah, let's do that.
Okay.
Wait.
Everyone in?
Okay. So you want me to read the first question?
Yeah, go for it.
Okay. Use the following information to answer the next 3 problems. Human blood can be classified into 1 or 4 basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. So there are the blood types, and so the blood types and the proportion given in the table above define a probability distribution, true or false.
I think it's
True.
true. I said bottom up. No, it's false. It goes to 0.99. I think.
Oh, where's my calculator?
I'm gonna do it one more time just in case. Oh nope, it's. I think I put 10 on accident, so it is true.
Oh, awesome. Yes, I just got one.
Okay. Perfect. I can go next. It says, what is the probability that a randomly selected person in the United States has O blood? So that would be
0.45, right?
Yeah. Luckily, that one just gives us right in the answers. That's kind of nice.
you know.
Yeah. Sometimes when it's too easy, I always think it's wrong.
You overget and I think it.
Yeah.
Jamie, do you want to take question 5?
Sure. What is the probability that a randomly selected person will not have type O blood? So then you just add them all together except for O, right?
Yeah.
Yeah.
So 0.55?
Yeah.
What I got.
Yeah.
Okay. I'll do question 6. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from the bladder cancer patient. Tingle, one of the dogs, demonstrates the identifications of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Question 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? So they said, how many bowls were there?
When you take
7 bowls.
6, when you take 1 and divide it by 6, is there 6 bowls?
Yes. And so that is 0.143.
1/4. Wait, what?
Let me try to do it again.
I got 0.167.
Yeah, that's what I did again, and that's what I got.
Mhm.
So 0.167.
6-7.
Okay.
All right, another good question. 6 is yours.
Okay, question 7, right?
Mhm.
In a combined total of 54 trials, the dogs correctly identified the specimens from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? In a combined.
There is little evidence, right?
Let's see.
Just because it's not even half the time.
Yeah, there were 54 trials and it's 22 times.
Do we know?
Unlikely.
No, that's kind of a tricky one.
I know. I'm rereading.
We had that something similar in the class, and it was that it's above the mean. There is like a probability that the trial could be true, but in this case, it's little. It's under 54.
It's under, yeah.
So
But if we get it wrong, there's another attempt, right?
Yeah.
yeah.
And before we move on, really quick, question 6, I was just re-looking at it, and it was 6 of the samples were from patients who did not have bladder cancer, and 1, so there were 7 altogether. So I redid the math, and so since it's 1 divided out of 7, it's 0.143.
You're right.
Yeah, so I just checked that really quick.
Thanks. All right.
Zero.
Good thing that you caught
143,
that.
right?
Yeah.
Yeah, 0.143.
Okay. Number 8 says M&Ms are small chocolate candies. The M&Ms website previously indicated in the United States the distribution of the colors in a bag of plain M&Ms is given in the following table. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red color candy? So wouldn't that just be 0.13?
Yep.
I would assume.
I feel like that's too easy.
But the individual quiz wasn't the hardest thing in the world either.
That's true.
Like, it had questions like this.
Do you think that is a 0.13?
So is that what we're going with for 8?
Yeah. The next one's gonna be a little harder because that's for the green one.
Oh, what is the probability that it would be green? Oh. Don't you just
0.16, I think. Because you add them all up and then subtract that from 1, right?
yeah.
Yep, that's what I got as well.
I got 16.
Yeah.
Well, 0.1.
Yeah.
Yeah, that's what I got as well. I think calculations like that.
Perfect.
Whose turn is it to read? I can read it.
Okay.
What is the probability that a random selection candy is not green? So why don't we just add all of the ones up that aren't green?
Yeah, so 0.84.
Yeah.
Yes. Yep. 0.8. Alrighty.
Okay. You want me to read?
Mhm.
Yep.
Use the following information to answer the next three questions. The ACT score of students admitted to a medium-sized public university in the Western United States were taken from Carpex.com. The following summary statistics were calculated. Okay, so question 11. Half of the observations are less than less than or equal to the number. Okay, half of the observations.
Is that the median?
24. The medium, right?
Yeah, that's what I'm guessing.
It's the one that's being.
It's the one that's in the middle.
Yeah. Yep. Okay.
I can read the next one. Based on the information in the table above, the top 25% of students scored above which number? Isn't that 22?
The top 25% of the students? So does that mean the highest?
Just 1 second. On 11 is the middle, right? So we have.
Okay, based on your information in the table, top the 25% of the students scored above what number? So we have to go back to the quartiles.
I thought Q1 was 25%,
Q1 is 25.
2 is 50, 3 is 75.
Yeah.
But
But
the top 25%.
that's what throws me off is the fact that it says top 25 because that's like the third quartile, isn't it? With the higher
Yeah.
scores?
Yeah,
Yes.
that's what it is.
It would be 27.
Mm-hmm.
I think it's 27.
If it just said the 25th percentile, I think it would be the quartile one, but it says top, so
Yeah. Good catch, Sergey.
Well, they would have scored above 25% because then there's 25% left,
mm-hmm.
right?
Sure, I think so.
So are we going?
Can we go to question 11? Half of the observations are less than or equal to the number. So it's 1, 2, 3, 4, 5, 6, 7.
11
9,
was the medium.
1, 2, 3, 4, 5. So on 11 is 22.
24.
The medium. Yeah. No.
Yeah.
Okay. So.
Is everyone good with question 12? I do think it's the 27.
Okay. Yeah, we have another chance anyway, so.
I can take the last one. So, the switch of the following statement is not one of the three rules of probability.
It's the third one, I think.
Yeah, if the probability is high, then the probability is positive. Yeah, that's not one of the rules. Awesome.
Alright, let's submit this. So the only one we missed was number 7.
Dang.
Oh, well, at least we know it's the other one. That's kind of nice.
I know.
Oh, awesome. Way to go, guys.
I'm just gonna get that one right.
Okay. So did anyone need help with any of the other questions?
I don't think with this lesson. I started at 5 today because tomorrow I don't have time to like do it tomorrow before the meeting, and so I have like a couple tomorrow, but just like one. But other than that, I think I'm good for today's lesson.
Alright. So do we just want to call it good and meet tomorrow and just redo the quiz if needed?
Yeah, we can do that. You guys probably still need to do 5 too, huh?
Yeah, I still need to do 5. I haven't looked at it.
Yeah.
Yeah.
Okay.
I don't think that lesson 5 is that easy. I was trying to do it today, like before the
I did
meeting.
it too, and it was just took me like 2 hours just to go over material before I even like.
I think that's gonna be a little painful.
What's the topic for 5?
It's a lot. It's more probability, but it's just like more in depth. It's not like super hard. I think it's just time consuming. And like there was a couple questions that I didn't understand. I was like, what the freak? But if you just watch the videos, it like makes a lot of sense. And it's just. And then I watched when I did the preparation. I watched the guy do the preparation on the side, and he does the same thing. And I just kind of learned from that. And then I did the homework, and then I just used my homework or use my preparation for my homework and like compared what I did with each one. It's just time consuming. I feel like this one is, but it's not like I don't know.
I don't know. Did you guys get a chance to review the lesson 5 or not?
I haven't looked too in depth at it yet. I just kind of glanced at it.
I can just tell you, I forgot what it's about in the first place. I can.
It's all about probabilities and
Like the curve.
if you guys do. I was working on question 2 and then I just